It's Thursday, the 5th of September 2024. These are the science and space headlines we're following on Talkin' Science. Starliner's crewed return to Earth scrapped. Kanyini launches onboard Transporter-11. And NEOWISE shuts down for the third and final time.
21 years online. From Star Trek to science and space. And we're not stopping. This is Talkin' Science.
Welcome to the show. Well, in a stunning and frankly embarrassing development for Boeing's space program, NASA has decided to return the Starliner capsule to Earth without its crew and have competitor SpaceX bring them home next year. The uncrewed return allows NASA and Boeing to continue gathering testing data on Starliner during its upcoming flight home, while also not accepting more risk than necessary for its crew. That crew, astronauts Butch Wilmore and Sonny Williams, will continue their work formally as part of the Expedition 71/72 crew through to February next year. They'll then fly home aboard a Dragon spacecraft with two other crew members assigned to the agency's Crew 9 mission. Starliner is expected to depart from the space station and make a safe, controlled, autonomous re-entry and landing in early September. This all follows helium leaks and thruster failures during the test flight of the Boeing craft back in June. South Australian-owned and manufactured satellite Kanyini has been successfully launched on board SpaceX's Transporter-11 mission from Vandenberg Space Force Base in California. Kanyini is the first state government-funded satellite in the nation and was built by a local team of South Australian-based companies. The $6.5 million mission is helping to create high-tech jobs in the state's space sector and develop vital space capabilities for South Australia. Now that Kanyini is in orbit, the next milestone for the project is to establish stable communications through an operations centre located at Innovor Technologies in Lot 14 in the heart of Adelaide. Once fully commissioned, Kanyini will deliver critical space data for use by government and research institutions, particularly in the areas of sustainability and climate impacts. Engineers on NASA's Near-Earth Object Wide Field Infrared Survey Explorer mission commanded the spacecraft to turn off its transmitter for the last time at the end of July. This concludes more than 10 years of its planetary defense mission to search for asteroids and comets, including those that could pose a threat to Earth. NASA ended the mission because NEOWISE will soon drop too low in its orbit around Earth to provide usable science data. An uptick in solar activity is heating the upper atmosphere, causing it to expand and create drag on the spacecraft, which does not have its own propulsion system to keep it in orbit. During its operational lifetime, the Infrared Survey Telescope exceeded scientific objectives for not one but two missions, starting with the Wide Field Infrared Survey Explorer mission. Managed by JPL, WISE launched in December 2009 with a 7-month mission to scan the entire infrared sky. By July 2010, WISE had accomplished this with far greater sensitivity than previous surveys. A few months later, the telescope ran out of coolant that kept heat produced by the spacecraft from interfering with its infrared operations and observations. NASA extended the mission under the name NEOWISE until February 2011 to complete a survey of the main belt asteroids, at which point the spacecraft was put into hibernation. Analysis of this data showed that although the lack of coolant meant the space telescope could no longer observe the faintest infrared objects in the universe, it could still make precise observations of asteroids and comets that generate a strong infrared signal from being heated by the sun as they travel past our planet. The space agency brought the telescope out of hibernation in 2013 under the Near-Earth Object Observations Program, a precursor for the agency's Planetary Defense Coordination Office, to continue the NEOWISE survey of asteroids and comets in the pursuit of planetary defense. By repeatedly observing the sky from low Earth orbit, NEOWISE created all-sky maps featuring 1.45 million infrared measurements of more than 44,000 solar system objects. Of the 3,000 plus near-Earth objects it detected, 215 were first spotted by NEOWISE. The mission also discovered 25 new comets, including the famed comet C2020 F3 NEOWISE that streaked across the night sky in the summer of 2020. An decommissioned NEOWISE is expected to safely burn up in our planet's atmosphere by the end of the year. Well, US scientists say it may be possible to use metal nanorods made from Martian iron and aluminium to thicken Mars's atmosphere, which would trap heat and potentially melt ice under the planet's surface to provide water to sustain life. The nanorods would be aerosolized, turned into a very fine dust, and blasted into Mars's atmosphere, amplifying sunlight and blocking heat from escaping into space, the researchers say. Their computer simulations of the approach suggest nanorods could be 5,000 times more effective than other hypothetical strategies, which focus on using greenhouse gases to warm the planet. But don't book your ticket just yet. They add that their approach would take centuries to work and isn't even guaranteed to make the planet's surface habitable. Damn. A first-of-its-kind archaeological strategy adapted for space has revealed how astronauts actually use areas aboard the International Space Station and how that differs from their intended uses. The findings provide glimpses into how astronauts adapt to life and conduct research without gravity, and how they use their space for work and leisure while in orbit, and more. Led by archaeologist Associate Professor Alice Gorman from Flinders University and Professor Justin Walsh of Chapman University in California, the International Space Station Archaeological project adapted the traditional archaeological test pit for a space setting, launching the project onto the ISS in 2022. While Earthbound archaeologists dig 1 metre squares to understand a site and strategise further study, the ISSAP team had the astronauts use adhesive tape to define 1 metre areas of the International Space Station and document them with daily photographs to study how the spaces were used over 60 days. The squares were placed in a handful of work and leisure locations on the space station, including a US galley table, workstations, experimental express racks, and on the wall across from the latrine. The authors say the findings demonstrate how traditional archaeological techniques can be adapted to study remote or extreme habitats, and gives a unique insight into how astronauts adapt to space in a way that may not be captured by interviews with the crew. Lastly this week, a long-standing conspiracy in astronomy that stars and dark matter are interacting in inexplicable ways has been overturned. The conspiracy emerged to explain how the density of matter in different galaxies appeared to be decreasing at the same rate from their centre to the outer edges, something that remained a mystery for close on a quarter of a century. It continued to elude astronomers because galaxies are diverse, with many different ages, shapes, sizes, and number of stars. So why would they all have the same density structure? The research team observed 22 middle-aged galaxies to find out, peering back some 4 billion years into the past due to their great distance from Earth. In extraordinary detail, using the European Southern Observatory's Very Large Telescope in Chile, they found the answer. It enabled them to create more complex models that better captured the diversity of galaxies in the universe. Dr. Caro Darkeen, the first author of the paper and an Astro 3D researcher from Macquarie University, along with her colleagues, found that the similarity in density might not be due to the galaxies themselves, but in how astronomers were measuring and modelling them. Fascinating stuff this week. Well, Trekzone membership gets you in first. First releases and first details. Sign up today to get early access, and we're zooming in very close to my chin there. We don't need to do that. Sign up today. Get early access to the next. Let's very quickly zoom out, if you please. Sign up today and get early access to the next Trekzone event. Recording it live always has its perils. Facebook, Instagram, X, TikTok, and YouTube Shorts all have podcast highlights, so find us where you are. For now, this is Talkin' Science for the 5th of September, 2024.